Okay, today we're doing Module 2, Lesson 26. Okay, I think there's 29 lessons total, so we're getting towards the end of Module 2, only a couple more lessons. And today your learning goal is to be able to use the standard algorithm to divide decimals by whole numbers. Okay, so that means one of our numbers is going to be a decimal, and one of our numbers is going to be a whole number. Which number will be the decimal, the whole or the divisor? If we're going to divide decimals by whole numbers, which one will be the decimal, the whole or the divisor? The whole. And our divisor will be a whole number, okay? It's kind of confusing. The whole is a decimal, but the divisor is a whole. Weird, right? Okay, good. Now, let's talk about the problem. It says, Jenny says that 77 divided by 8 and 95 divided by 10 have the same value because they both have a quotient of 9 and a remainder of 5. The question's asking, is she correct? Explain why or why not. And the important information are our two equations are 77 divided by 8 and 95 divided by 10. Let's do these problems first. If I have 77 divided by 8, how many times can 77 go into 8? 9. What's 9 times 8? 72. And how much do I have left over?
5.
My remainder is 5. Is that smaller than my divisor?
Yeah.
So is Jenny correct that the answer for 77 divided by 8 is 9 remainder 5? Yeah. But does the remainder of 5 have a value? Yeah. How many? This is 5 what's? What's the unit of this 5? Ones, right? Could I regroup it? It would become 50 what's? Tenths, right? So how many times can 50 tenths go into 8? 6 what's? 6 tenths, right? Because 6 times 8 is 48. And what do I have left over? 2. That's 2 what's? I can tell it's 2 tenths because it's in the same column as the tenths, right? But I could regroup it, right? I could regroup this as 20 what's? Hundredths. Yeah, all I have to do is add a 0 here, and brother can bring that down, and all of a sudden I have 20 hundredths. I can tell it's hundredths because the right hand, the 0, is in the what's column? Hundredths. How many times does 20 go into 8? 2. Okay, so I'm going to put a 2 in the hundredths column. 2 times 8 is 16, and so what do I have left? 4. What's the unit? Hundredths. I can tell because, again, it's in my hundredths column. Can I regroup that? Yeah. 4 hundredths becomes 40 what's? Thousands. Good, because if I put a 0 in the thousands and bring it down, it's 40 thousandths. If I have 40 thousandths and I want to put it into 8 groups, how much would go in each group? 5 what's? Thousands. So I have to write the 5 in the thousands column. Okay, that's 40. And I have nothing left over. So that remainder of 5, the quotient was 9, right? And the remainder was 5. What was the value of that remainder? 625 thousandths. Okay? Now let's try it for the other problem. 95 divided by 10. I have 95 ones. How many times can that go into 10? 9. And so when I multiply, I have 90. And is it still 99 remainder 5? Is the answer 9 remainder 5? Yes. But if we want to find the value, does 9 remainder 5 have a value? No, but we can find its value, right? I can regroup those 5 ones as what? 50 tenths. If I have 50 tenths, how many times does that go into 10? 5 tenths times, right? So the value of the first 9 remainder 5 was 9 and 625 thousandths. The value of the second 9 remainder 5 was 9 and 5 tenths. Do they have the same value? So even though Jenny found that this was she right that this was 9 remainder 5 over here? Was she right that the second problem was also 9 remainder 5? But do they have the same value? So just because you have the same quotient and the same remainder, can you prove that it doesn't have the same value? Yeah, and you can do that by doing the decimal division. Today we're going to learn how to use the standard algorithm to divide a decimal by a whole number. Again, you can see that you have a decimal in the whole by a whole number divisor, okay? We need to always estimate before we can divide. And we learned how to do this yesterday, okay? When we estimate, what do we round first, the whole or the divisor? Divisor. The divisor is 22. It's pretty close to what number? 20, okay? And then what number would be compatible with 20? 60? We could do 61s. Could we do anything that's more compatible? Like 758 tenths? Would that work? 750 tenths? Can we do that? Let's do that. Okay. What about 600 tenths? Would that work? Okay. 600 tenths divided by 20 would be, how do I write it in 2 steps? 600 tenths divided by what? Divided by what? 10 divided by 2. Okay. Then we can do it in 2 steps. What's 600 tenths divided by 10? 60 tenths. Again, I'm going to say this like a broken record. It's super important that you always write that place value. How could we tell in the beginning that it was 600 tenths and not 600 ones? So if we have 60 tenths divided by 2, what do we have? 30 tenths. What's the standard form of 30 tenths? 3.0. So this tells us, our estimate tells us that our answer should be pretty close to 3. If it's not close to 3, we're not on the right track. Okay? All right, let's move on and let's do the division. Okay, now that we know that our answer should be pretty close to 3, let's do the division. We have 75.9 divided by 22. How many tens do we have? How many tens do we have? 7. Can I divide 7 tens into 22? No. So then I have to think about it. I have to regroup it into 75 ones, right? Can I divide 75 ones into 22 groups? Yeah. How many times can we do it? Well, if I do it 1 time, how many will I use up? 22. If I do it 2 times, how many will I use up? 3 times? 4 times? So how many times can I do it? 3. Is it 3 tens or 3 ones? Be careful, okay? Because a lot of people, a very common mistake could be to write the 3 right here because it's my first number. Would that be correct? No, because I'm dividing 75 ones, not 75 tens. Be very careful. Some of you were talking during that time, so you didn't hear the explanation. 3 times 22 is 66. Sister will subtract. Now, you know, 5 minus 6 is negative 1. So what do I need to do? Regroup. 15 minus 6 is 9. And 6 minus 6 is 0. Okay, so is my answer 3 remainder 9? No, I can continue regrouping, right? This remainder right here of 9 is in the what units? Ones. But I can regroup it. 9 ones can become 90 whats? Tenths. And then I bring down the 9 tenths I already have. So how many tenths do I have? 99 tenths. Okay. How many times can 99 tenths go into 22 groups? 4. But it's 4 whats? 10. So I have to add this decimal point right here. It's super important that the decimal point always just goes up the elevator. Okay. 4 times 22 is 88, right? When I subtract that, what do I have left? 11. Is it 3.4 remainder 11 tenths?
No.
No, because those 11 tenths can be regrouped to be?
110 hundredths.
Yeah. Okay, and I have 0 additional hundredths to bring down. Okay, 110 goes into 22 how many times?
5.
5. Perfect. 5 times 22. Now, if you're not someone who can do this in your head, conveniently, I forgot, but over here, there's a scratch area because I can do 5 times 22, right? 2 times 5 is 10. 2 times 5 again is 10. Oops. Yeah. So if I add that up, I have 110. So I write that over here, and I subtract it, and my remainder is 0. So that means my answer is 3.45. Now, let's take a look at our estimate. What was our estimate again? 3.0. Is 3.45 pretty close to 3.0? Yeah. Very good. Before I can write my final answer, I need to check, right? Yeah. What do I do to check my work? I have to take my quotient, which is 3.45, and multiply that by my divisor, which is 22. As you can see, if I wrote my quotient right here, 3.45, I divide this way, which means I would multiply this way. So is it 3.45 times 22? Do you see how it's going the other way? Good. Can we do this multiplication? But we need to first do what?
Change.
Good. What would the change be? Okay, if I do that, then my multiplication problem is 345 times 22. 2 times 5? 2 times 8? 2 times 4?
8.
Plus 1?
9.
2 times 3?
6.
Good. Put a 0 because now we're working in the tens. And did we already do 2 times 345? 690, right? It's going to be the same, so you just copy that. And then I can add them up. Okay, 7,590. But because my change was times 100, my undo needs to be divided by 100. And if I divide that by 100, what do we get? 75.9. Is that what we want?
Yeah.
We are happy, so we can put a big check mark. So then our answer that we're going to box is 3.45. Looking at this problem, are the two wholes the same? 520.3 and then 52.03. Are those the same?
No.
They have the same digit, but what's different?
The
The decimal is different. Okay, what about the divisor? Here we have 43, and here we have 43. Is it the same?
Yes.
Okay, so we're dividing by the same number of people, right? In both cases, we're dividing by the same number of people. So which one will have a bigger answer? The one where we started with 520.3 or the one where we started with 52.03?
The first one.
The first one will be bigger, right?
Yeah.
Because we're starting out with more stuff. How does this whole, 520.3, compare to this whole, 52.03? How does it compare? Rohan?
520.3 is 10 times.
It's 10 times bigger. So then this answer, which we don't know yet, is it going to be bigger or smaller than this one? It's going to be 10 times smaller. What's 10 times smaller than 12.1? 1.21. So go ahead and write that down. And I want to prove it to you, okay? So let's take a look. The reason why I wrote the standard algorithm is because I want to show you this. Look, in our original problem on the left, 52 tens can go into 43 one time, right? In this case, the 52, this is tens, yes? Because it's in the tens column. Now, what about over here? 52, is it 52 tens?
No.
Now it's 52 whats? Ones. So that's why now the 1 is in the ones place. Do you see why place value is so important?
Yeah.
Okay, it shifts